You guys saw different types of energies, right? That is kinetic and potential energy. In potential energy, you guys saw the gravitational potential energy, and then spring, due to which the potential energy is stored in a body, correct? Now, this video you will see different types of energies. Okay, under that the first one is heat energy, okay, or thermal energy you can also say. Now, heat energy is one of the most intrinsic property of any material. Okay, now when we talk about heat energy, now lot of examples we can give, like friction. One of the best examples is friction. So when you are cold, you rub your hand, the heat energy is liberated, correct? So whenever heat is liberated, we call that as exothermic reaction. Okay, so like whenever heat is released, like it could be firing a matchstick, to friction, to even an atomic bomb explosion, anything, they're all exothermic reactions. Okay, there is one more type which is endothermic. Endothermic is where heat is absorbed. Okay, for example, turning of ice into water. So there it's becoming colder and colder and colder, correct? So these are endothermic reactions. Even that also you can give as an example, or you can also say fusion. Okay, nuclear fusion is an endothermic reaction. After that, that becomes an exothermic. Whereas to start a fusion, you need to provide it heat. Okay, now see, lot of examples we can give. Now, even a simple example, if water is there on the walls of a room, then that room will become cold because water absorbs the heat which is there in the room. Okay, even this is one of the examples of endothermic reaction. Okay, now heat energy or thermal energy, lot of examples you can give. I want you to come up with your own examples and think about it. Okay, so this is one type. Now another type is a chemical energy. Now, by far from the history of mankind, chemical energy has played a very important part, because see, the first initial most thing like fire. So what we started using logs, correct? Wooden logs. That's again chemical energy. That is there, when you burn the log, you're converting that chemical into heat energy, right? After that, then they started with petrol and diesel and oil, kerosene, all those things. Again, all chemical energy, right? Even small batteries also, they are also chemical energy. So chemical energy has been one of the most useful types of energy. Okay, now since we have different types of energies, let's move on to electrical energy. Now electrical energy, I don't have to tell in detail about how do we use electrical energy, because day-to-day life, every day we need electricity. See, irrespective of whether it's maybe your phone, your laptops, or to any of the things, for communication, for transportation, for anything and everything, we use electrical energy, right? Okay, now the next thing is a nuclear energy. See, nuclear energy, it's you can say it's quite new meaning I'm talking about 19th century or maybe around 1930s 1940s time. So nuclear energy is the energy stored inside the nucleus. Okay, now when we say it is stored inside the nucleus, how do we get that energy out? Because we cannot sit and break the nucleus just like any other material, how we break using hammer, obviously, right? Now for that, what we do is bombardment of particles. Okay, so you have two types of nuclear reactions which is very popular, and you guys already know that, fission and fusion. So fission is where the nucleus splits and it releases energy. That's what happens in any nuclear reactor. Alright, then you have nuclear fusion, where two lighter nuclei will combine to form a bigger one. There also energy is released. Okay, now we have nuclear fission, where energy is released as splitting of nucleus, and nuclear fusion, where energy is released because the two lighter nuclei combine to form a heavy one. Alright, now why energy gets released? So there is something called as mass energy equivalence. Now famous Einstein's equation, E is equal to mc square. This gives us the relation between energy and mass. Okay, now any nuclear reaction happens, there is something called as mass defect. That is, the initial mass of the particle and the final mass of the particle, it won't be the same. Okay, there will be defect in the mass. Now that mass defect gets converted into energy. Now how much of energy is created? That is given by E is equal to mc square. Alright. Now see, what we say is, since we are talking about nuclear particles, they are very small, correct? Now we represent the energy of those using electron volt. Alright. Now 1 electron volt is 1.6 into 10 to the power of minus 19 joules of energy. Now whenever we say that fission has happened, we represent the energy in terms of electron volt. Like 931 mega electron volt of energy is released when one uranium atom splits. Okay. Now like this, we try to give mass energy equivalence. Using that, we actually get how much of energy is released when fusion happens or fission happens or whatever. Okay. So different types of energies. I know this is not the end of types of energies. You have n number of energies, types of energies. I want you to list out all of them and think of different examples for each.